Hey mathematicians, today we are going to multiply fractions. So go ahead and write that as your title. And then we're also going to put today's date. Alright, so I decided to bake my children a cake. They love sweets. So do I. Alright, so there's my cake and I'm going to frost 3/4 of it. Okay, so one of my kids doesn't really like frosting, so I'm not going to frost the whole thing. I'm only going to frost 3/4 of it. So 1, 2, 3/4. Okay, so let's just write that little note right there. So we're going to frost 3/4 of the cake. So go ahead and draw that picture. You can just use your pencil to shade. Okay, some of my kids really like sprinkles. So I decided that I'm going to put sprinkles. So I'm going to put sprinkles on half of what is frosted. So not on the whole thing, just on what's frosted. And I'm going to put it on half. Okay, so I'm just going to take the cake. I'm going to divide it right in half horizontally. And I'm going to go ahead and put those sprinkles on half of what is frosted. Yummy, yummy sprinkles. And so what fraction of the cake has sprinkles and is frosted? So what fraction has sprinkles and is frosted? We'll just say frosted with sprinkles. Well, you can look at the cake and you can see the answer, right? Right, so we have 3 out of how many pieces are frosted with sprinkles? So 3 out of 1, 2, 3, 4, 5, 6, 7, 8. So we have 3 out of 8 pieces that have sprinkles and frosted. So that would be our answer to that question. Okay, so you might be thinking, okay, Ms. Johnson, well, how does that relate to multiplying fractions? You said that's what we were learning today. All right, so let's take a look. All right, so it says that I had put sprinkles on half of what is frosted. Right, so let's focus on that statement. So I put sprinkles on half of the frosted cake. All right, well, what fraction of the cake is frosted? What fraction is frosted? Well, 3/4 is frosted. So I'm taking half of the 3/4. I don't know if you knew this or not, but in math, that word of means to multiply. So I'm taking half of 3/4, so I'm saying 1/2 times 3/4. Now we already know what the answer is from our picture. Our answer is 3/8. So do you see a relationship there? Do you see what's happening? Yeah, hopefully you can see. We have 1 times 3 is 3. And then we have 2 times 4 is 8. So when you multiply fractions, it's so much easier than adding and subtracting. You're just multiplying the numerator times the numerator to get the numerator in your answer, and then you're taking the denominator times the denominator to get the denominator of your answer. So it is so much easier. You don't have to find a common denominator. You don't have to do any of that. So much easier than adding and subtracting. Okay, now, just like with any other fractions, we do have to worry about simplifying. Okay, so we're going to talk about simplifying when we multiply the fractions. Okay, so let's say we have a half again, so 1/2, and let's say we want to multiply it times 4/5. All right, so we said we multiply numerator times numerator and denominator times denominator, right? Okay, so we're going to say 1 times 4. So 1 times 4 is 4. And then denominator, 2 times 5 is 10. So it's 4/10. Hopefully you can see that that needs to be simplified. We can simplify it by 2. So 4 divided by 2 is 2, and 10 divided by 2 is 5. So when we simplify it, we get 2/5. And we simplified after we multiplied. But there's a way that we can simplify before we multiply. All right, I'm going to show you that way. So we have 1/2 times 4/5. And what did we simplify the first one by? We simplified it by 2. So we're going to simplify by 2 before we multiply. So I'm going to look, to do that, you look at your diagonals. Okay, so you look at the values that are diagonal from each other. So I'm looking at the 1 and I'm looking at the 5. And I'm thinking, okay, can I simplify 1 and 5? You're almost thinking about it. You can think about it like, okay, if it's 1/5, would I be able to simplify that? Well, no, you can't. Right? You can't simplify 1/5. So we look at our next diagonal. So our next diagonals, oops, I didn't mean to erase the 5. So our next diagonals are the 2 and the 4. Okay, so let's think about that like 2/4. We would simplify that by dividing by 2, which is what we divided by here, right? So I'm going to take the 2 and the 4, and I'm going to simplify it by 2. So I'm going to say 2 divided by 2 and 4 divided by 2. So 2 divided by 2, I'm going to cross it out because the 2 goes away, because 2 divided by 2 is 1. And I'm going to cross this one out, 4 divided by 2, because the 4 is going away and I'm replacing it with a 2. Now I'm going to multiply straight across. So I'm going to say 1 times 2. Remember, the 4 went away. So I'm saying 1 times 2 is 2. And 1 times 5 is 5. Notice we got the same answer both times. Just one time we simplified before we multiplied, and one time we simplified after we multiplied. Now I'm going to encourage you to simplify before you multiply. It makes your math easier. You might say, well, Miss Johnson, that was pretty easy to simplify at the end. That's true. It is. It's either way, you're going to get the same answer. But I encourage you to simplify before you multiply, because as your numbers get bigger, if you have big numbers, the math is easier if you simplify before. Okay? All right, so we're going to write down our procedure for multiplying. Okay, so go ahead and write down the first step. So we make all the values fractions. And then if the value is a whole number, you have to make it a fraction by placing the whole number in the numerator and making the denominator a 1. So go ahead and pause the video so you can write that real quick, and I'm going to show you an example. All right, so if I have a whole number of 5 and I need to multiply by 5, I need to make that a fraction, and I do that by saying 5 over 1. Remember, this means 5 divided by 1. Well, we know 5 divided by 1 is just 5. So we're not changing the value. The value is staying the same. We're just putting it in fraction form. Okay, and that works for any whole number. So 18 would become 18 over 1. If I have 2,000, it would be, to make it a fraction, I would say 2,000 over 1. Now, if the value is a mixed number, we have to make that an improper fraction as well. So go ahead, pause the video, write that down. Okay, so if I have the mixed number, let's say 2 and a half. Okay, a lot of kids call this, what we're about to do, Texas, because you got a little T and then you have a little X, like our abbreviation for Texas, right? Okay, they call it Texas. All right, so we're going to multiply our denominator times our whole number. So we're going to say 2 times 2 is 4. So 2 times 2 is 4, and 4 plus 1 is 5. So 2 and a half equals 5 halves. All right, let's practice with another one. Let's say I have 3 and 5/8. Okay, so again, a lot of kids call it Texas. So we're going to say 8 times 3. So we're going to say 8 times 3 is 8, 16, 24. And 24 plus 5 is 29. It's going to be 29/8. Notice the denominator stays the same, because remember, that's the size of our piece. All right, let's try one more. Let's do 5 and 3/4. So I'm going to say Texas. I'm going to say 4 times 5 is 20, and 20 plus 3 is 23/4. Okay, our second step is we want to simplify if possible. Whenever you simplify, you must simplify a numerator and a denominator. You cannot simplify numerator, numerator, and denominator, denominator. You have to simplify a numerator and a denominator. After you simplify, you multiply straight across, numerator times numerator, and then denominator times denominator. And then our last step is we check to make sure if it can be simplified, we need to simplify it. Okay, so go ahead and write those steps down. Pause the video, write those steps down, and then we're going to do some examples. All right, so example number 1. All right, number 1, we're going to do 9/10 times 4 and 1/6. 9/10 times 4 and 1/6. Okay, so first step is to make them all fractions. So 9/10 is already a fraction. So that means I need to do, oops, sorry about that. That means I need to do Texas on the 4 and 1/6 to make it a fraction. So I'm going to say 6 times 4 is 24, plus 1 is 25. So I'm doing 9/10 times 25/6. All right, now I want to see if I can simplify. So remember, when you do that, you look at your diagonals. So I'm going to look at 25 and 10 and say, okay, can I simplify 25 and 10? Is there a number that can go into 25 and 10? And yeah, it's 5. 5 can go into 25 and 10. So I'm going to say, oops, my 5 disappeared. Sorry about that. All right, so I'm going to say divided by 5, divided by 5. Now, you're going to get to a point where you're not going to need to write those little division signs right there. But because we're just learning it and we're starting it, I want you to write them, okay? So I'm going to cross 25 divided by 5 out. And I'm going to say 25 divided by 5 is 5. And then 10 divided by 5 is 2. So the 25 and the 10 are gone, and our new values for that are 5 and 2. Okay, now I'm going to look at the 9 and the 6, and I'm going to say, okay, can I simplify that? Is there a number that goes into 9 and 6? Yep, there is a factor that goes into 9 and 6, and it is 3. So I'm going to say, I divide both of them by 3. So I'm going to cross out 9 divided by 3 is 3, and 6 divided by 3 is 2. Now, some kids, they look at this and they say, that's too much, Miss Johnson. It's just too many numbers. I understand. So if you need to rewrite it, rewrite it. Okay, so you have a 3 in the numerator now and a 2 in a denominator. So 3/2 times, and on this one you have a 5 in the numerator and a 2 in the denominator. All right, so if you don't need to rewrite it, you don't have to, but a lot of kids need to rewrite it because they need to get rid of all that jumbled stuff, okay? So now we're going to multiply straight across. So I'm going to say 3 times 5 is 15, and 2 times 2 is 4. And then my last step is to simplify if possible. So can 15/4 be simplified? Yeah, it can't because that's improper, right? So to fix improper, we're going to divide. Remember, we do NITO. The numerator goes in and the denominator goes out. So I'm just going to kind of do it up here. So 15 divided by 4. So 3 times 4 is 12. Subtract. I get 3 left over. Remember, our remainder becomes our numerator and our denominator stays the same. Right? So the remainder becomes the numerator and the denominator stays the same. So our answer will be 3 3/4. All right, example 2. All right, example 2, we're going to do 5/8 times 12. Okay, so our first step is to make them all fractions. So 5/8 is already a fraction, so I'm just going to leave it. Times, now 12, we have to make 12 a fraction. And to do that, all we have to do is put it over 1. Now I'm going to look to see if I can simplify. So I'm going to look at my diagonals. I'm going to look at 8 and 12. I'm going to say, okay, what number can go into 8 and 12? Or is there a number that can go into 8 and 12? And there is. 2 can. So can 4. So we want to use the greatest common factor. So 8 divided by 4, I'm going to cross that out. 8 divided by 4 is 2. And 12 divided by 4 is 3. Now look at 5 and 1. Can I simplify 5 and 1? Nope. So I just leave those alone. So if you need to rewrite your fractions, go ahead and rewrite them. If you don't need to rewrite them, that's okay. All right, now we're going to multiply straight across. I'm going to say 5 times 3 is 15, and 2 times 1 is 2. All right, our last step is to look to see if we can simplify. So I notice that 15/2 is improper, so that means I need to divide it. Do NITO, so numerator in, denominator out. Remember, your remainder becomes your numerator, and your denominator stays the same. So our answer is 7 1/2. All right, make sure you have all that written down. All right, and example 3. Let's do 12 35ths times 15 16ths. Remember the beginning where I was talking about I really want you to simplify before because it makes it easier? Think about this question, how hard it would be if we multiplied 12 times 15 and got an answer, and then multiplied 35 times 16 and got an answer, and then had to simplify it. Like, that would be super hard. Look how much easier it's going to be if we simplify before. Okay, so we're going to look at 35 and 5. What number can go into 35 and 5? Yep, 5. So we're going to divide this by 5 and this by 5. So I'm going to say 35 divided by 5, cross it out, that's 7. 15 divided by 5 is 3. Now I'm going to look at 12 and 16. Oops, sorry about that. 12, 16. What number can go into 12 and 16? 2 can, 4 can, 6. No, 6 can't. So let's use 4. So I'm going to say 12 divided by 4 and 16 divided by 4. So 12 divided by 4 is 3. And 16 divided by 4 is 4. I look to see if there's any other simplification I can do, any other numerator and denominator, and there's not. So that means I can multiply straight across. Okay, rewrite it if you need to. If you don't need to, you can just focus on the 3 times the 3. That gives us 9. And then 7 times 4 is 28. And then, but remember, if you need to rewrite it, rewrite it. That's fine. All right, and we think, can we simplify 9/28? Is there a value that can go into 9 and 28? So 2, no, 3 can go into 9, but it can't go into 28. 4 can go into 28, but it can't go into 9. 5, 6, 7 can go into 28, but not 9. So it's simplified. So our answer is 9/28. So simplifying before we did our multiplication made it much easier than if we had waited to the end to simplify. Okay, so that's why I want to really suggest that you simplify before. Okay, all right, let's do one that's the numbers aren't quite as big, but I wanted to make sure you saw an example that looked like this, because sometimes kids get this one confused. Okay, so we look at our diagonals. So we have 5/9 times 3/5. So we look at our diagonals and we say 3 and 9. Is there a value that can divide into 3 and 9? Yes, and it is 3. So we're going to cross out. 9 divided by 3 is 3, and 3 divided by 3 is 1. Now we have 5 and 5. Is there a value that can go into 5 and 5? Yeah, it's 5. Right? So some kids get that confused. In fact, I love it when I see the same value in the numerator and denominator, because it means my multiplication is going to be super easy, because 5 divided by 5 is 1 and 5 divided by 5 is 1. So I know it's going to make it a lot easier. So I get excited when I see the same number in the numerator and denominator. All right, so we're going to say 1 times 1 is 1, and 3 times 1 is 3. So our answer for that will be 1/3. All right, what y'all think? One more example? We'll make it 5 examples. Yeah, let's do 5 examples. All right, so let's do 1 3/4 times 20. Okay, so our first step is we have to make them fractions. So I have that improper fraction. I have that mixed number, so I need to make it an improper fraction. I'm going to do some Texas there. So I'm going to say 4 times 1 is 4, plus 3. 4 plus 3 is 7. So that's going to be 7/4 times 20. Needs to become 20/1. Right? Can I simplify? Can I simplify 1 and 7 or 20 and 4? Yep, we can simplify 20 and 4. So I'm going to divide by 4, divide by 4. So 4 divided by 4 is 1. 20 divided by 4 is 5. Now I'm going to multiply straight across. So 7 times 5 is 35. And 1 times 1 is 1. Can I simplify 35 over 1? Yes, 35 divided by 1 is 30. Messy. Is 35. Okay, so we did 5 examples, and I hope that helps you. You are going to need to practice this. Practice, practice, practice. Remember, the only one who learns math is the person who's doing the math. Okay, so make sure you have your notes all copied down with all the examples so that when it's time to practice, you have something to look at.